Mark,
Hey, David.
how are you tonight?
Good. How are you?
Good. Thanks for sending me these 4 pictures. I probably received this picture 4 different times in the last week. I have a lot of Chatfield geometry students. So, where would you like to begin? Since we have just a half an hour, I don't think we'll be able to cover all 4 pages, all questions, so you kind of need to direct my attention.
All right. Well, we could start with number. We could do number. We could skip down to, I think, 15.
Okay. I was going to say, let's make sure we do the ones you have trouble with, not the ones you understand.
Yeah.
Okay. So 15, what kind of quadrilateral is that?
It looks like a square.
Yeah. Why?
Because it has
Why is it a square?
Well, it's got even sides on all 4
4 equal
sides.
sides, but that could be a rhombus also.
It has equal angles too.
That makes it a square. The fact that it has 4 equal sides and 4 equal angles makes it a square. How about 16?
That looks like a rectangle.
And 17?
Is that a rhombus?
Well, yeah. In other words, the definition of a rhombus is 4 equal sides. And they only tell us that that's equal to that. But the other thing about a rhombus is that the opposite angles are equal and the diagonals make a perpendicular line. So as long as I have 4 equal sides, and even if I only know 2 of them are equal, the fact is if I know that's 140 and that's 40 and that's 140, well, I know that they have to total 360, so that has to be 40. And now I'm looking at 2 equal sides and opposite angles are equal. That says rhombus.
Okay.
And the fact that it's a rhombus means all 4 sides are equal.
All right.
All right. So let's talk about a rhombus one more time. The most important thing you can know about a rhombus is there are 4 equal sides.
Okay.
Second, it's always a parallelogram. I cannot draw a quadrilateral with 4 equal sides without making a parallelogram. Okay?
Yeah.
Thirdly, the diagonals bisect one another. Meaning that's equal to that, and that's equal to that. Okay?
Okay.
And fourth, the diagonals make a right angle at their intersection. That's what you want to know about a rhombus. Oh, and opposite angles are equal, and adjacent angles are supplementary, like any parallelogram. In other words, if I draw a parallelogram that's not a rhombus, I still have that angle equals that angle, and I still have this angle equals this angle, and any adjacent angles are supplementary, always. In other words, this and that add to 180, this and that add to 180. The difference is that if I take my parallelogram that's not a rhombus, and I draw the diagonals, they're not perpendicular.
Okay.
They might bisect one another. I kind of think they do. I'm not real certain right off the get-go whether they do or not. but I believe they bisect one another, but they are not perpendicular. And
All right.
the way to handle some of these figures, let's say you didn't remember whether they were perpendicular or not on a parallelogram. Well, draw a very, very exaggerated parallelogram. Now, if I draw the diagonals on this parallelogram, it's clear they're not perpendicular, right?
Yeah.
That is definitely not a right angle. They do look like they bisect one another, though. And in point of fact, they do. In other words, the diagonals do bisect one another, even on a parallelogram, not just a rhombus. And the reason they do is because that triangle is congruent with that triangle.
All right.
Ooh. Now, and that, I believe, makes that equal to that, and that equal to that, which means they've bisected one another. The question is this equal to this, and that equal to that instead? Now, we don't have enough time to go into that, but I believe they do bisect each other even on a parallelogram.
What about a trapezoid?
Trapezoid is a quadrilateral, but it's a unique quadrilateral in that it only has two parallel sides. The other two sides are by definition not parallel. Okay? If the other two sides were parallel, we would have a parallelogram. It wouldn't be called a trapezoid. So a trapezoid is specifically only two parallel opposite sides. What's wrong with this error analysis? What's wrong with this first statement? That's a rectangle.
We don't know that the line bisects
It definitely does not bisect it. In other words, if I had a square, well, yes, that bisects it because that's 45 and that's 45. And you know that's 45 because a square has equal sides, and equal sides mean equal opposite angles, so that has to be 45. Okay? But if I draw a rectangle, and now I draw a diagonal, well, I know that that side's not equal to that side, right?
Yeah.
So there's no way that this angle is equal to that angle, which means it can't be 45. That's more like a 20-degree angle and a 70-degree angle. But the fact is, there's no way this can be 45. And if that's not 45, it's not equal to that angle. Okay?
Yeah.
So the problem with this statement is you cannot say that angle equals that angle. What can you say about these two angles? In other words, what should this first line read?
They're equal to 90 degrees.
Exactly. So this first line should be 7x minus 4 plus 3x plus 14 equals 90. And then you can solve for x. I haven't gotten to the second page hardly with anybody. But I have an hour-long geometry session tonight with a student that's been having a problem sending me his stuff. So I really appreciate this because it's all of your classes are the same there.
No problem.
So I'll have his stuff also. Classify the quadrilateral and find x and y. What kind of quadrilateral is that?
It looks like just a square.
With a 104-degree angle?
Just kidding. That's a rectangle.
No. Rectangles don't have 104-degree angles either. Remember, squares and rectangles have all 90-degree angles.
Okay.
So this has a 104-degree angle. It looks like a right angle, but they've labeled it, so we know it's not. But
okay.
It has 4 equal sides. What kind of a quad is that?
Well, could it be? I don't know.
What quadrilateral has 4 equal sides?
I know.
Rhombus.
Okay.
That's the definition of rhombus. 4 equal sides. It doesn't have 90-degree angles necessarily, but it has 4 equal sides, and they're parallel. And that's a parallelogram also.
Okay.
And which means I know adjacent angles are supplementary. So the moment I know this is a rhombus, what's x?
X is equal to
Correct?
76, yeah.
Correct. And what equation can I write to solve for y?
Well,
Y plus 8 equals what?
104?
No. Y plus 8 is the measurement of the side AB.
Okay. Well, does that mean y plus 8 is equal to 3y? Okay.
You got it. That's what,
Yeah, I thought it said
these
something
hash
else.
marks mean. Is those hash marks mean the side lengths are the same.
Okay.
Allows me to write this equation, solve that for y.
If y is equal to 3y is equal to 8, then y is equal to
Hold on. What's the first step in solving this?
simplify.
Gather your variables all on one side. Gather
Okay.
everything else on the other. That's always a step in algebra problems. In other words, at some point in solving an equation, you have to always do that. Gather all your variables together. Which side are we going to gather the y's on?
The left side.
I would rather do the right. Why? Because it'll leave a positive coefficient.
Okay.
If I gather them on the left side, I'm going to have a negative coefficient.
All right.
So to gather them on the right side, I need to do what?
Subtract y from the right.
That leaves
And then add it to the left.
What's 3y minus y?
2y.
What's y?
Oh, y is equal to 4.
There you go. Notice that it's a little bit easier. If I go the other way, I've got a bunch of negative signs. In other words, if I bring the 3y over to there, I got minus 2y. And then I got to take the 8 over to the other side. Now I got 2 negative signs. I still get the same answer, as you should. But to me, if I can reduce the incidence of negative signs, I always do. It doesn't matter whether your variable's on the left or the right side of an equation. But you'll make fewer mistakes if you have fewer negative signs. Okay, all of these geometry problems, and this is probably this is going to be the case for the rest of your geometry course. Everything comes down to algebraic equations. In other words, when you get a problem like this, it merely allows you to write the equations. What what can I tell about this figure? What kind of quadrilateral is that?
It's just a rectangle.
Okay. Could also be a square, but I don't know. It doesn't look like a square. But I know it's a rectangle because it's got 4 90-degree angles. So
Yeah.
now what equations can I write? What do you know about rectangles?
They have two sets of parallel lines.
And they're equal. They're not just parallel, they're equal. In other words, KL is equal to JM. So what equation does that translate to?
2y plus 35 is equal to 4y plus 5.
Solve that quickly.
Let me get a calculator, sorry.
No, you don't need a calculator. Which side am I going to put the y's on?
The right.
Okay, what are they?
2y plus 5 equals 35.
Okay, now which side am I going to put the numbers on?
The left.
So what number goes on the left?
30.
What's y equal to?
15.
That's why I said you don't really need a calculator there. And
Okay.
what equation can I use to solve for the x's?
Oh, you could kind of do the same thing. You could do 5x minus 9 is equal to x plus 31.
It's interesting how you go right to left, and you went bottom to top. There's nothing wrong with it. I just find it interesting. I tend to go left to right. In other words, I would have written this like this, and you would have written it back. Not backwards, because your 5x minus 9 equals x plus 31 is just as good as mine. It's just I go from left to right and top to bottom. And one is not more correct than the other. So what's the next line?
Add 9 on both sides. Yeah. And then 6x there.
Be careful. You have to subtract.
Oh, 4x.
You have to subtract an x. And let me give you a clue. If that's what you did, notice that x is not a whole number anymore. Not that it has to be, but every problem we've done, the variable ends up being a whole number. So that's a red flag that you made a mistake. If we put the proper number in there, we get x equal 10. And so far, everything we've gotten, the variables are whole numbers, not fractions. So when you get a fraction, just double check and see whether or not maybe you made a mistake.
Okay.
All right, 28. What kind of a quadrilateral is that?
That one looks like it's just a square.
Yeah, we got 4 right angles. How do we know it's a square?
It has the angle bisector makes a 90-degree angle.
Yeah, the diagonals is what those are called.
Yeah.
In other words, these two diagonals, if they make a 90-degree angle, then you have a rhombus. And a rhombus that has 90 degrees here is a square. Okay, so what equations can I write? I presume this 5x means this angle right there. What is that angle?
90 degrees.
No, that's the whole angle.
Okay, so half of it should be 45.
Right, so 5x equals 45. So x equals 9, we can do immediately.
Yeah.
And wow, is that true? If x equals 9, does that equal 45? Yes, it does. 3 times 9 plus 18 is 45. We didn't even need that though. But
well, isn't 5x the alternate interior of 3x plus 18?
You're right. So I could have also said 5x equals 3x plus 18. which gives me 2x equals 18, or x equal 9 also. But I didn't even need that information because I knew that the diagonal bisects that right angle into two 45-degree angles in a square. So how do I solve for y? Now, this time, I don't think y, notice there's no degree mark. This had x degrees, so I knew they were talking about this angle.
Okay.
But this time, the 2y refers to the measurement of half that diagonal.
Okay.
What equation can I write? That's what this 10 also refers to, is the measurement of that.
2y is equal to 10.
So y equals 5.
Yep.
Okay. Notice we never needed that. They could have not given us that, and we still would have been able to answer all of that. Kind of a figure is this?
That one is a rhombus.
Rhombus, the main thing that describes a rhombus is 4 equal sides.
Okay.
What's the next thing that it might be? You have rhombus?
Trapezoid?
No. Here's your 4 sides that you're dealing with. Squares, rectangles, rhombuses, and parallelograms.
Okay, so parallelogram.
4. Right. Parallelogram is 2 equal and opposite sides that are also parallel. Okay? So they tell us that side's equal to that, and that side's equal to that. That says parallelogram to me. And what else do we know about a parallelogram in terms of angles? Same as rhombus. Opposite angles are what? If I draw a parallelogram like that.
Yeah.
This angle is equal to that angle. And this angle is equal to that angle. So opposite angles are equal and adjacent angles are supplementary with all parallelograms. So what equation can I write here?
Well, you could do 4x plus 7 is equal to 5x minus 6.
Solve that real quick.
So we have 1. X is equal to 1?
Got to add 6.
Okay, so x is, we have x and then also 13. Yeah.
Okay, that's a mistake you've made twice, so let's go through it. What I'm doing is I'm subtracting 4x from both sides.
Okay.
That's the first step. Okay, cancels there, so I have 7 equals x minus 6. And now the 6 is being subtracted. So I always have to do the opposite. If it's being subtracted, I have to add 6 to both sides. Now I have x equals 13.
All right.
And what about y?
Well, y we could, that's referring to the sides, right?
Yes. There's no degree notation there. Sometimes it can be tough to tell, and that's the only information we really have, is they'll put the degree sign there if it's an angle, and if there's no degree sign there, then it must be the side length.
Okay. So 2y plus 1 is equal to y plus 3?
There's an advantage when you go right to left. I just realized what it was. It gets your variable on the left side. When I do it the way I wanted to do it, my variable always ended up on the right side. What's the next line? Do both steps in once?
You could, alright, so we have y is equal to 2.
You got it.
Awesome.
All right. That's probably a good place to stop. Since we only have 2 minutes, I don't think we have time to do another one of these problems, and I do have a 5 o'clock. So,
All right.
Mark, I will talk to you on Thursday at 4.
Okay, cool.
Thanks. Have a good one.
Thanks, Dave.
Bye-bye.